Welcome to QDL. QDL is your look at who and what is making news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest. So today we're going to talk about smart manufacturing. What is it? Okay, so this is actually pretty funny. If you look up smart manufacturing in Wikipedia, it has a warning, Wikipedia does, at the very top of the page. And the warning says this: this article appears to contain a large number of buzzwords. And the first paragraph in Wikipedia reads in part, smart manufacturing is a broad category of manufacturing that employs computed integrated manufacturing, high levels of adaptability and rapid design changes, digital information technology, and more flexible technical workforce training. Smart manufacturing has interoperable systems, multi-scale dynamic modeling and simulation, intelligent automation, strong cybersecurity, and network sensors. So, all of that's true. It has all those things. So, what's smart manufacturing? Well, fortunately today we have Paul Rogers, President of the North, South, and Central American regions for Hexagon Manufacturing Intelligence, which is involved in smart manufacturing, to tell us what smart manufacturing looks like really on the ground, from the shop floor. What does smart manufacturing actually look like? Hi, Paul. Thanks for joining us.
Hi, Dirk. Excited to be here, and you sort of took my definition away from me on smart manufacturing.
We got to be sure we get all those buzzwords in there. So, I mean, before you came to Hexagon, you are known as a digital innovation strategist. I believe that's part of the reason you were brought on to Hexagon. So you understand these topics, and you've worked in it for a long time. So, what is the simplest definition of smart manufacturing?
It's a great question, and it should be relatively simple. And yet, the Wikipedia page is correct in that there are a million buzzwords, there are a million descriptions. Part of that is smart manufacturing is a journey. It isn't a single thing. But when you look at big corporations and the journey that they've been on over the last 20 years, there have been all of these initiatives and all of these technology breakthroughs like cloud computing, so you have software anywhere. You have things like smartphones, where you have communication anywhere. You have big data initiatives that I think we're all aware of, so you have large-scale data analytics. And then you have things like machine learning and AI techniques, ultimately all put together take you on a journey for industrial IoT. And so when I think in terms of smart manufacturing, if you are executing or implementing elements of those categories, or you're putting those categories together in a very advanced way to optimize your manufacturing equipment or to optimize your manufacturing processes, you're on a smart manufacturing journey.
When you say optimize, you mean optimize in not just making individual machines, I don't know, more productive, more efficient. You're talking optimize in terms of how the entire factory communicates with each other?
It's a good way to look at it. You can optimize your individual pieces of equipment, and that's usually a first step in a smart manufacturing journey. When you start putting those pieces of equipment together as subsystems, now you're starting to create an overall optimization to your manufacturing facility. And so now you're affecting throughput. One of the easier examples to think of from an optimizing a small piece of equipment is to think in terms of a motor or a pump, usually very critical to a manufacturing environment. Machine learning is a fantastic method for doing predictive failures. So in the past, you had software that would monitor pumps and motors, and they could give you all the parameters as to whether that motor was operating effectively. Now you have machine learning and AI techniques that can actually use the data around the motor, and based on its health, it can start doing things like predicting when that motor is going to break down. So it could give you a statistical probability that that motor is going to go down in the next 3.5 weeks, which then ultimately allows you to prepare for that motor replacement, and thus gave you some component efficiency.
So just sticking with that, just really briefly before we move on. So in the past, that wear may have been simply something that was measured by an operator. They might go out and periodically pull a tool off the, I don't know, off the CNC or something, measure it just to make sure it's still sharp, or they might measure some other characteristics of that tool, and based on that decide, okay, I think it's time to do some maintenance on this or whatever. You're saying part of the smart manufacturing is that is being done automatically and being fed back into the tool?
That's a great example. In the past, you'd have scheduled maintenance. And so maintenance for equipment was on a particular schedule. And then in between those intervals, you'd have surprises. You'd have a motor go down, and then you would have to take your whole manufacturing environment offline. With monitoring software and with predictive machine learning capabilities, now you can actually maintain the equipment based on its current health rather than some sort of randomly scheduled event. So you could maximize the use of that motor or maximize the use of that pump as you see fit, because you know its current health and you know its predicted health.
Okay, so that's kind of at an individual level. So now let's expand out from that a little bit to what I think most people, maybe incorrectly, and you can correct me if I'm wrong here, think of when they think smart manufacturing. So you hear all these terms, IoT, Internet of Things, machine learning, you just mentioned, artificial intelligence, big data, 5G, digital twins, that's a big one. Are all those part of smart manufacturing? And if so, how do they relate to each other, or how do they tie together? I mean, I know Hexagon's got bits and pieces of all of this, maybe they got all of it. How do these things communicate, and how do they complete the idea of what I think a lot of people think of when they think the smart factory as a whole?
All of those elements that you mentioned are part of smart manufacturing. Some are subcategories of themselves, like machine learning as a subcategory or a technique within artificial intelligence. But all of those elements that you mentioned either are used on an individual basis or used together, ultimately make your manufacturing facility smarter. And so they feed into each other. So you have cloud computing, so you have software anywhere. That's important because if you're now on the manufacturing floor and you have your mobile device, you have software anywhere. You have mobile capabilities. You can do things like troubleshoot your piece of equipment in real time because you have your mobile device that's accessing your software in the cloud. You have big data initiatives that have probably happened in your corporate. And because of those big data initiatives, now you have large scale usable data that your artificial intelligence engines are using to make sure that your equipment is healthy. And they're looking for operational patterns within your manufacturing environment to make sure that you're operating at maximum efficiency. And so each one of those in itself can take you or push you down your smart manufacturing journey. But coupled together, you're now reaching higher and higher levels of maturity in that journey.
If somebody wants to implement smart manufacturing on their, sounds like a great idea. What are the major roadblocks for fully implementing smart manufacturing on the ground? I mean, I don't think it's just as simple as we're going to buy a bunch of hardware, we're going to buy a bunch of software, and we're going to connect it to our network and get our Wi-Fi up and running. Everybody's got their smartphone and we're good to go. Smart manufacturing. It's not that simple, right?
It is not. And I think some of the challenges associated with going on a smart manufacturing journey is some customers and some OEMs do see it that simple. And that can typically lead to some disappointment because it is very much like a cultural shift. It's a cultural shift in thinking, and it is a journey. And so based on your current level of maturity in the smart manufacturing realm, you'll have a different starting point than maybe your competitor or maybe even your sister manufacturing environment. And so a lot of the challenges associated with these types of initiatives is there's a lot of inertia. A lot of manufacturing environments go, way back, and there is a lot of, I've heard this a million times. We've been doing it the same way forever, and it works for us, and so we'd like to stick to it. You have that sort of inertia, and then you have what we described earlier, a little bit of inexperience on both sides of the fence. You have inexperience in understanding what smart manufacturing is from a customer perspective and from a vendor perspective, not understanding that it's a journey. And because of that, and not knowing exactly what the art of the how is based on your current level of maturity, unrealistic expectations can be put in place. So it can be described as something as simple as buy all of these things and in 6 months you will be smart, versus thinking in terms of long term that you will become incrementally smart and you will reap the benefits of incremental efficiency, and then ultimately recognizing that this is a journey that actually never ends. Technology continues to get better, and the definition of smart gets a whole lot smarter down the road.
Okay, so you said a couple things there that are kind of interesting. So you're basically saying that the digital transformation, which is what we're talking about here, it's more than just a physical factory remake or simplifying production processes and so forth. You're saying that and you even use the term cultural shift. So what is your approach, and I know you've got experience in this, to help teams, help companies through the cultural shift that's kind of necessary to be successful in an increasingly digital environment? Like you said, that's the way we used to do it, but no, that's not the way we're doing it going forward. What do you do to kind of sell that and make that work?
It's a great question, and I think it starts with having a true understanding of where your customer is at in their digital journey. And so every customer has a different starting point, and I've got a lot of interesting stories of previous projects where each customer started at a different point, and each customer had a different definition of smart. And each definition of smart is correct relative to your maturity. It could be something very simple. It could be incredibly advanced AI techniques because of your level of maturity and in the journey that you're in. We've been very successful in the past, and certainly with Hexagon Manufacturing Intelligence, in doing a good job of recognizing where the customer is at in their journey, so that we have a good starting point and we have a strong ability to describe what that journey is going to look like in very realistic terms. The other key element, if you're going to be going on this journey and you want to make sure that everybody's grounded in that journey, you have to have very specific milestones for improvement, hit those milestones, and just make sure that those milestones are realistic.
So you just mentioned a couple of times that you kind of alluded that you've got some stories that you've already done some of this. Is there a story that you can share, an example you can share of where you have done this, where you've actually helped a company make this transition, and try to be maybe as specific as you can? I realize sometimes you can't mention a company or whatever, but I think what would be interesting to our listeners is to be able to see, okay, if you're able to do this, we brought in this kind of equipment, this kind of software. Here's what we kind of accomplished for them, even if it's only the baby steps.
Yeah, I do have a lot of stories. I've been doing this for 20 years. I was doing software optimization for coal-fired power plants in the late 90s. I have a story that is a different kind of manufacturing environment. And this story is super counterintuitive, but I think it describes the digital innovation journey of a new customer. And so we were working with a oil field operator. And so an oil field operator is a fancy term. If you were driving down a dirt road in Texas and you see the open fields and you see those little hobby horses going up and down, those little hobby horses are oil pumps, and they are pulling the oil out of the ground for wells that have been drilled. And if you're in Texas, you look through that field, you see that there are thousands of them just lined up in neat little rows. And so we brought this customer into our innovation center, and we prepared for several months to create a optimization software based on AI techniques to optimize that facility. So optimize the extraction of oil, reduce energy consumption, all kinds of really interesting and advanced techniques. We brought the customer in, sat them down, and we spoke to them for about an hour. And I was feeling pretty good about ourselves. We sounded very smart, and we were super prepared. And the customer stopped the meeting at about the hour mark and said, I love what you're saying, but could your product tell us whether our equipment is on?
Yeah, can I just know that?
We were dumbfounded because we were thinking, well, of course. But then they told us where they were in their digital journey and their value story. And so when we learned how important on off was, the way that they know whether this equipment is in the middle of nowhere, and the way that they determined whether it was running or not, they had a person driving up and down the dirt roads, visually looking at them. And when they weren't running, they would make a mark. And it took them upwards of a month to get that pump up and running again. And so the amount of revenue per pump over the course of a month was in the millions. And so on off became very important. And what we were able to do was multiple things that I mentioned before. We put cellular on their pumps. So because they're in the middle of nowhere, so we put cellular nodes on the pumps. Those cellular nodes put the information into a cloud. We then created a pretty nice piece of software for them to see their fields, and that pulled it off the cloud and put it on their mobile device. And all of a sudden, they knew exactly what was running, what wasn't running. And then we started the journey with them, and we eventually got their oil field to the product that I described when I first started the story.
That's interesting. It's funny. It's funny. You mentioned oil field. I think when people think smart manufacturing, they think manufacturing. They feel a building with four walls and a roof. But really, that is a manufacturing facility. It's just out in the open, and it's got a bunch of machines that you're simply monitoring those machines in the same way you would do in a factory floor. That's kind of an interesting idea. So one thing that occurs to me, and I asked you this because now you work for Hexagon. Currently, the state of affairs with smart manufacturing is, if a company wants to implement what you're talking about, and they've got various machines from various companies, they've got software from different vendors, and they're all supposed to be part of this smart manufacturing ecosystem. Is the state of affairs right now such that these all can communicate with each other, or is there compatibility issues where you might have a CNC, a smart CNC, and you might have a smart CMM, and you've got some other software that's supposed to, kind of be able to monitor both of those and give you dashboards? Is that really happening right now, or is there a need maybe for, I don't know, smart manufacturing standards, so to speak?
It's a great question, and very much like cell phones. Cell phones companies finally came together and created a standard, so all cell phones can call each other. In the manufacturing environment, almost all equipment still has varying protocols for communication. Some of that is because of legacy. I would say mostly because of legacy. There are a lot of communities out there that are trying to create standard protocols, and there are standard protocols for communicating depending on the type of machinery you have. It's just whether or not you as an OEM follow that protocol or not. But this is where we get into discussions like platforms and what we would call back-end integration platforms. Back-end integration platforms are the things that have what I call the secret decoder ring. It's the APIs that can actually reach out to competitor equipment, to your own equipment, and centralize that data and use that data in your products as well as your competitor products.
Last question here. Where do you see the state of smart manufacturing right now, and where do you see it going, I don't know, in the near term, 5 years, let's say?
Yeah, that's a great question. I have been on stage with a lot of futurists, and I thought, what a great job, you know. You get to predict, and so we'll record my prediction. um, when you look at the manufacturing floors that I've been exposed to, I have literally to this day been exposed to manufacturing environments that are still in the on-off stage. I have been exposed to some really incredible customers that are way down their journey. They've been using our scanning technology to create digital twins of automobile parts. So you've got automotive parts, and each one of those parts is scanned in real time. And that's, let's say, a digital twin of a door. Then using digital thread, which is a neat way of tying it all together. If you ultimately scan all the major components of a vehicle, that thread can pull them all together and determine whether that vehicle is going to fit together and meet specifications. And I think that's a great, really advanced way of understanding digital twins and digital thread, and ultimately why that's important. And I think that is a level of sophistication that is cutting edge right now. We hear a lot about digital twin and thread, but I don't see a lot of it out there in the for real stage. But I have been seeing it more and more. If we think in terms of what we're going to see in the next 5 years, I think it's going to be centered around artificial intelligence and machine learning. Being able to create optimization patterns for a full manufacturing facility is going to be critical to make sure that that manufacturing facility is operating at top efficiency at full time. And it's the techniques that allow you to know what is the current pattern of operation for you to be fully optimal. And it takes into account all the complexities of all the subsystems. And that gets back to our original discussion is are you optimizing the entire facility? And the answer is yes, once you've entered the realm of AI.
Well, we'll check back with you in 5 years and find out whether we've reached that or not. All right, Paul Rogers, President of the North, South, and Central America regions for Hexagon Manufacturing Intelligence. Thanks for joining us today. Appreciate it.
Thank you, Dirk.
And that is it for today's QDL. Thanks to all of you for joining us as well. As usual, if you have any questions that you'd like us to ask, if you've got any guests you'd like us to bring on or products, just let us know. You can email us at qdl@qualitydigest.com, and we'll do our best to make that happen for you. Thanks for joining us. We'll see you again. So long.